For some of you, last week's class want to know some of the logic between the math, some of the logic in the math behind the high-low method. This will help explain it. So, in the high-low method, we take basically points along a linear curve, a linear line. So, basically, a linear line has a slope. So as we draw a line, say for example, basically a scatter graph where we have the x-axis and the y-axis, for temperatures in Celsius, as they go up, our sales go up. As they go down, our sales slope down. As our temperature goes up, our slope goes up. So we have all these plots for x and y, and we do a graph. And as you can see, all these points are very close to the graph. Therefore, our r squared in a regression analysis must be pretty high, which means there's a direct correlation between this x-axis data and this y-axis data. So basically, in a linear equation, y equals mx plus b, where we have a fixed component and then we have a variable component, the coefficient of x. Basically, what that means is there is a slope, a rate of growth in this line. As each degree or each input on the x-axis goes up, the y result will go up by x, by a slope amount. In this graph, again, as we increase the x-axis, the y-axis goes up by a rate of growth. So what the high-low method is, essentially, is a slope. Let's say our y input, our highest input on the y is 440,000, the low is 220,000. And the input is 40,000 and the low is 15,000. Essentially, the 440,000 and the 220,000 represents y2 and y1. The x input is x2 and x1. So if you remember, the calculation of a slope of a line is y sub 2 minus y sub 1 divided by x sub 2 minus x sub 1 to get the slope. This gives you the rate of growth of that line. And that's what we're trying to figure out in a scatter graph. So the high-low method does take the high and the low. Again, not as accurate as regression analysis, because regression analysis will take all the costs in this range and all the input in this range and give you a linear line, okay, with an equation. Why the high-low method is a quick, fast calculation. So y2 minus y1, x2 minus x1 gives you 220,000 divided by 25,000 equals 8.8, and that's your x. What this is your mx in the y equals mx plus b. It's your variable part of your equation, your cost equation. So what it's saying is, for every additional input of x, whether it's direct labor hours or machine hours, or any input you decide to use, for any additional input in x, y will increase by 8.8. So if we simply take the 8.8 and multiply it by the highest input of 40,000. 40,000 times 8.8 gives us the total variable component of y equals mx plus b. So the total variable component is 350, is 40,000 times 8.8. In this case, 352,000. We take the highest cost, which is 440,000, and we subtract the variable cost of 352. So if total cost minus variable cost must equal our fixed cost. So 440 represents total cost, 352 represents the variable part of our cost equation. Then the difference between total cost and the variable equals fixed, because fixed plus variable cost equals total cost. Which is 88,000. Therefore, our total cost, which is y, will equal 88,000 as our fixed plus 8.8x will be our formula. So that's essentially the explanation of the math behind high-low. It's simply the slope of a line. Then we try to figure out what the total variable costs by taking the input times the variable by the slope to get the mx. Subtract total costs from the variable to derive our fixed. So the fixed plus the variable component equals our equation. Thanks for watching.